So the next talk will be given by Audrey Looby. Sorry. Okay.
Awesome. Hi everyone, my name is Audrey. I'm a Banting postdoctoral researcher from the University of Victoria, and I'm also one of the co-leads of the Fish Sounds effort, a working group of researchers, data managers, educators, and graphic designers, some of whom are listed here. And I want to thank many of the previous talks that have already given excellent introductions to underwater soundscapes and even perfectly foreshadowed the main topics of my talk today, which will be the sound-producing fishes and invertebrates. Their sounds include what I'll refer to as active sounds that are used in communication, and there are also passive sounds that are produced incidentally during other activities like swimming or chewing, but that may still serve some signal functions. So for today, I'll discuss a couple of global syntheses that our research group has conducted on underwater sound production in fishes and invertebrates. I'll use that data to highlight a few known soniferous species from African waters. And then I'll wrap up by sharing some upcoming projects and opportunities related to that ongoing fish sounds effort you keep hearing about. So let's dive into our data. So this work started with one seemingly simple question: what fish species make sound? And to answer this, I conducted a systematized review to create a global inventory of what fish species have been tested for sound production and which ones were reported to produce sounds. I've updated my original review several times so that I have now assessed over 3,000 references for relevance and collected data from over 1,000 of those references, encompassing the years 1874 through 2023, and over 1,200 species that have been examined for their sound production. Let's see if we can get it back. Awesome, okay. So for actively soniferous fishes, those species that use sound for communication, in terms of who, I found 1,048 known actively soniferous species. And these are spread throughout 153 fish families and 51 orders globally, though with still some select taxa that were not found to make active sound when studied. These actively soniferous species also included many that could be relevant for passive acoustic monitoring applications, including those that are fished, used in commercial aquaculture, or are introduced or invasive. And this brings me to my first African species highlight. Cichlids are among the most well-studied soniferous fish families, both globally and in Africa. And this particular species is endemic to the shallow shoal pools of Lake Tanganyika in East Africa and is popular in the commercial aquarium trade. It has been studied for its sound production across several publications over the past 50 years, contributing to topics on the behavioral implications of both active and passive sound production, noise impacts on communication, and the role acoustic signaling can play in speciation. And soniferous fish species like this are not just widespread taxonomically, but also geographically. In my review, I found at least one actively soniferous fish species native to every region globally except for in and around Antarctica. And this is likely more due to limited research effort in those regions, and I'm hoping some more recent work will soon help fill in the gaps in this map. Actively soniferous fishes were also found in every water type, climate zone, and demersal pelagic category as defined by FishSpace, and included almost 500 known species found in the waters in and around the African continent. And while my data shows the breadth of sound production to a variety of underwater environments and species, there is still ample room for discovery. For example, the Breed River redfin, an endangered minnow from South Africa, was the first of 475 species of African cyprinids to be recorded producing active sounds, only reported as recently as 2008. Paul Skelton, one of the authors of the study, told me he expects many more freshwater fishes contribute to African soundscapes, but that they can be difficult to study, in part because of the dangers of swimming in a lot of the continent's rivers. And after seeing some very intimidating hippos this past week, I can agree with what he's talking about. So that leads me to the question of how many more soniferous species might be out there and how well are we doing in discovering them? Well, through a recent data effort between glubs, which will be the topic of the next talk, as well as worms and fish sounds, we suspect as many as 2/3 of the about 35,000 extant fish species could be considered likely to produce active sounds. However, using rarefaction and extrapolation techniques on my review data, I found that doubling all of the scientific effort over the past 150 years might only find 500 new actively soniferous fish species, and even fewer would be heard or recorded producing active sounds. So this demonstrates current inefficiencies in actively soniferous fish species discovery, which we've been hearing a lot about, especially today. And this also hints at the potential benefits of developing citizen or community science efforts to help describe the sheer diversity of fish sounds that might exist. Now, what about passive or incidental fish sound production? So though I found quite a lot of species that have been studied for passive sound production in the literature, it paled in comparison to active sound production in my review, and so there's probably a lot more we can learn about it too. And even though we still have a lot more to learn about fish sound production, it's still been relatively well studied compared to the next topic I'm going to talk about, underwater invertebrate sound production. And similar to our question for fishes, we were curious which invertebrate taxa make underwater sound. And luckily for us, there have now been several different recent global reviews of underwater invertebrate sound production. So this time we sought to fill gaps and expand on these efforts. So to do this, we conducted another systematized literature review to quantify the number of aquatic invertebrate taxa observed to produce sound, how they do so, and how they were studied. This work is being led by Brittany Spreel as part of her master's thesis, mentored by myself and my collaborator, Kieran Cox. And through searching in Web of Science and collecting additional references to identify novel taxa, we found 97 references studying underwater invertebrate sound production from the years 1948 through 2023. Brittany completed this data collection from all of these references just a couple of weeks ago, and so we've only just started to explore the results, but I'm excited to share some of our preliminary findings with you all today. So in all of these references, we found 100 taxa identified to class or lower that were found to produce active and or passive sounds, ranging from worms to copepods to octopus and sea urchins. We chose not to include aquatic insect taxa in our review as they were very well described in a separate effort. And though we did include other freshwater invertebrates, the vast majority of the soniferous taxa were marine. And these soniferous taxa were spread across 4 phyla and 12 classes, with arthropods and mallocostracans like crabs, lobsters, or shrimps being the most common taxonomic groupings. For example, the European spiny lobster produces ultrasound screeches as well as rasps that can be detectable over several kilometers. These sounds offer promise as a passive acoustic monitoring tool of particular import, as the spiny lobster is a popular commercial fishery in countries like Morocco and Tunisia, with many populations considered vulnerable due to overfishing. So among the soniferous taxa identified in our review, there was a mix between those that produced active sounds, passive sounds, both, or whose intent could not be determined. This is a stark contrast to the fish sound production literature, where you may remember the vast majority of studies were focused on active sounds. And this mixture is exemplified by one of the most ubiquitous underwater invertebrate sounds, those produced by snapping shrimp. So this particular species of snapping shrimp is native to the east coast of Africa, as well as much of the Indo-Pacific. And as Ashley touched on yesterday, snapping shrimp produce explosive snaps when stunning prey or for territorial behavior. And this particular species may even use them to communicate with co-habituating crabs. So snapping shrimp sounds could therefore be considered either actively or passively produced, depending on the context. Now, despite our data encompassing several species native to African waters, studies occurring at African institutions or locations were very underrepresented in our data set. And part of this may have been on us, because we primarily focused on collecting additional references outside our search string which reported novel taxa. In other words, we didn't catalog every paper that documented snapping shrimp sounds, for example. This nonetheless still highlights the ample opportunity for further research on the variety of invertebrates found in African waters, and we hope that the quantification of data gaps like this can help inspire and provide justifications for future studies. So in summary, sound production is widespread among fishes and invertebrates, with many taxa and geographic regions represented, but we still have a lot more to learn, particularly for invertebrates and African underwater soundscapes. And with that, I thought I would take the time to highlight some resources and ongoing opportunities related to our fish sounds effort and data offerings. So as I mentioned, I'm one of the co-leads of the Fish Sounds effort, which has created a compilation of fish sound production information and over 1,200 representative recordings available for you to explore, adapt, or use for your own research. And these are both at fishsounds.net and our associated data repository on Borealis. And I'm excited to announce we've just launched version 3 of the website this past weekend, which will now have all of my review data up to the year 2023, which you all got to see today, as well as several new recordings and some reorganization to improve website functioning and navigation. Future updates will improve our sound visualizations, add our invertebrate data, and continue updating our information and recordings. So, if you like, you might consider sharing your research recordings or photos with Fish Sounds to help with your own discoverability. To be included on the website, we have several different policies to help keep our data processing and size feasible, including requiring recordings be associated with a publication. However, we recognize that there are many valuable recordings that don't fit our criteria, so we've launched a new initiative in collaboration with Dr. Jack Greenhalgh, great, okay, to collect published or unpublished freshwater sound recordings, including those of citizen scientists. You can visit our project webpage for more information, and we hope to do similar calls for other recordings in the future. Next, if you or someone you know is an undergrad studying in these different countries or regions and are interested in spending a summer in Canada, then I would recommend checking out the MyTax Global Link Summer Internship Program, which provides a stipend, travel funding, and research mentorship matching. Our group has collaborated with 4 excellent interns from this program to date and will continue to do so in future years. And we're very open to other opportunities to collaborate as well. Finally, if you're interested in outreach related to sounds underwater, with our latest website version, we have also released a Biology of Sounds in the Sea workshop template with associated games, worksheets, coloring pages, and presentation slides, some of which you even saw in my talk today. These resources are available in both English and French and can be easily adapted to a variety of different groups or applications. So in summary, I don't have all the answers to all of our challenges that we've been hearing about in the conference, but I hope all of these global data sets, resources, and our ongoing efforts can help serve the African bioacoustics community, as well as advance our broader understanding of underwater soundscapes globally. So with that, I want to acknowledge all the people and institutions who have been involved in this work so far, and I'd be happy to take any questions now, or you can definitely reach out to me online. Thank you.
Thank you, Audrey. We have time for questions. So, any question?
Yes.
Thanks, Audrey. That was great. Tremendous effort. And I look forward to using Fish Sounds and contributing in the future. I'm curious what the invertebrate sounds, you say you haven't put them online yet. Can you give just an idea of, out of those 100, how many were recorded in situ, how many were in tanks, things like that? Was there
Yes.
obvious trend?
Yeah. So we did collect information on the recording environment that they were tested in. I don't know well enough off the top of my head, but I do believe it was a pretty even mix among them, yeah.
Okay. Any other question?
Audrey, hello, it's me. Maybe slightly tangential, but yeah, we work on cetaceans that all make noise, and we're always saying, oh, it's the best way to communicate underwater. Why don't more fish make noise?
So we suspect that many do, but that they might just be rarely produced, or that they might be quiet or hard for us to discover. And so with the idea that maybe 2/3-ish might make active sounds for communication, for why more of them wouldn't outside of that, Aaron Rice's work did an evolutionary ancestral state reconstruction analysis of sound production in fishes and found that it evolved independently about 33 different times across the fish family tree. And a lot of those were through processes like exaptation, and so using existing structures for sound production. And so because of how many times it evolved, maybe it didn't evolve universally and without a common ancestor like you might find with marine mammals.
Okay, thank you.